Hey everyone, in this video I want to talk about verifiable credentials, the ability that I can maintain control of various identifiers that represent me or some other entity in the real world, but still have them trusted by relying parties that I want to present them to. If I think about me as a human being, my human identity, so I have me, I have John. What is my identity in the real world? Is it things I say about myself? Well, the reality is things I just say about myself, some receiver of those things, who cares? I could be making things up. They're not going to trust the things that I just say about myself. I could be a mad person. People would probably assert that I am. It doesn't matter what we say about ourselves in most circumstances. Now, sometimes we can. Hey, what's your shoe size? Fine, people will take that, it doesn't matter. But for things that really are important, really our identity in the real world is the sum of what trusted or the majority will attest about me. I could think about saying, well, okay, my citizenship. People don't care what I say, people would care about some institution, institutions have columns always, some institution would create some credential for me. Hey, a driving license. They'd give me this driving license that they have created with various claims about me. My name, my date of birth, whatever. They issue this to me. I store it. I have a wallet. Hey, I have a wallet and governments would issue me a certain credential. And it has claims about me in that credential. And when I give it to someone, they can verify it's authentic. They have holograms and watermarks and all different things in those that I could then put in my wallet. And I could then use this to go to another company, say, hey, I want to get a job. So they check my driving license and then they give me a credential from them. And I can get these whole sets of different credentials, including a Blockbuster video card, which is super useful. But I get these verifiable credentials of the real world that I can put in my wallet and I can present to people. And I can give it to this person. They do not have to directly communicate to the government. There's no direct communication required because this credential, it is able to be proved because those holograms, because of those artifacts of the actual credential. So it could be, hey, John is a certain citizen of a country, John works for a certain company, John eats a lot of pizza. The pizza restaurant would attest to that. John has a YouTube channel with over 100,000 subscribers. These are all artifacts that help me prove things to others without the person I'm trying to prove it to, the verifier of this proof, having to have a direct relationship with that issuing party. And again, all those different credentials fit in my wallet. They adhere to a certain standard. I could have any wallet I want. This one just happens to be a Minecraft wallet, but it doesn't matter. They follow a certain set of standards for the credentials of the real world I could put in there. And even if the government was shut down, this still works. I can still give it to people and it would be trusted and usable. So there's a certain isolation protection. Once I've been given that, I can carry on using it. Now let's think about my digital life. So my digital self, okay, so now we'll have a digital John. Do I have my own identity in the real world? Well, no, I really don't. What happens here is in the virtual world, there are various identity providers. Now, this could be a Google, it could be a Facebook, it could be a Microsoft. There are many of these organizations out there. And in some way, I'm able to prove to them, hey, I own this identity they essentially are leasing to me. It's not really mine in a lot of ways. They could absolutely go and give it to someone else. So they hold a digital identity And I have to go and prove, hey, yes, here's my username. Maybe here's my password. Maybe I'm using MFA, whatever that is, to be able to then go and use that identity. Phone number. It's not really mine, it's a telephone company's. There's an area code, they have it. A website, there's a central authority that give out the domain names, but there's ways to go and challenge that. And so I have many different accounts. I have a work account, I have social accounts, there are bank accounts, I have educational institutions. So what I do is, for these various identity providers I might use, there are apps out there that I can tie that federate to particular identity providers. Now, I may have different islands of security world. For example, I might have a work persona that my work app's tied to that certain identity, but then I might use a completely different identity provider for apps that may be more social, that are more personal in nature. So I could absolutely end up with these different identity providers, but all of those, they really own that identity. And you see this all the time now. If I go to almost any site, so I'm just going to pick a sales site over here. Oh, it's offering me good sales. I'm not interested in this. But if I was to say, hey, I want to sign in and I don't have an account, notice we have this option. I could create a local account, or, hey, look, do you want to sign in with one of these identity providers over here? It's a very common thing we see all of the time. And so what those are really doing is they're federating to those particular identity providers. So over time, more and more of the applications I use, the data I have, is tied to some identity that's centralized. We have these central identity providers. They are holding and really own that identity. We're, at best case, leasing it from them. So we're making a trust decision in those identity providers that they're going to do their due diligence, they're going to make sure it really is me. But there's challenges with that. I am trusting them. This IDP really has all of the control. I don't really have control of these identities. So the IDP has control of what I consider my identity. I could lose the identity. It could be, hey, I delete it. I might violate some terms of use. They may go out of business. Now, the bigger identity providers, that's very, very unlikely. But I could lose that identity. So this identity I have, well, it's not portable. It's really tied to that particular identity provider. And as I add more and more apps to be trusting, well, one of the things I'm going to be concerned about is data breaches. Something happens now, everything that I tie to this identity could be exposed. My privacy. If I use this one identity over many sites, can they start to track and correlate what's happening? And do I really have, well, data shared? How do I have confidence that they're not oversharing? I give some app access to some particular aspect of my digital identity. Do I trust that? Do I trust Google or Facebook or Microsoft isn't maybe oversharing or has some problem where it's oversharing my data? Maybe even these relying parties, if I keep using the same identity, could start to correlate and work things about. So really, there's a lot of risk with this. I've seen the net with Sandra Bullock. They deleted all her identities. She ceased to exist even in the real world, pretty much. So there's challenges with this central approach. I do not really have fine-grained control of what people want to see. And think about who's really in the center of this picture. You've got the various apps. There's me, but it's the identity provider. They are at the center of this all-up picture. And that's really not what I want. If I think about this is my digital self, and as we think more and more important about those digital identifiers that represent entities in the real world, I want to be in control of that. I do not want all of these concerns. So if I could start fresh, what would the solution be? Well, the ultimate solution would be me as John. I would actually be my own identity provider. The identity provider of, now I'm saying John, but realize this could also be organizations. When we talk about these concerns about the identity, it's not just human beings have that concern, it could be entire organizations. It could be I want some identifier for my dog. It could be an identifier for a building. It might be an identifier for a child who's not yet able to self-govern, self-control an identity for them. But I would want this ability, ideally, that I am my own identity provider. I create my own identifier, and I'm in control of it. That's all nice and ideal, except we come back to that same problem as the real world identity. Real world identity, hey, I can make claims about who I am. They don't care. Self-attestation is generally not that useful for many things. So absolutely, hey, I'm my own identity provider. I could make up some claim about myself, some digital claim, and I could do some self-attestation. But most of the time, that person I'm sending to it, that organization that I'm sending it to, we call this a relying party, or in this case, they're going to verify that attestation I'm doing. Do they care about a self-attestation? They really don't. What they really want more the idea is someone else who's more trusted will issue some kind of verifiable identifier, some verifiable credential for me that they would trust, just like I was given a driving license. But I want it decentralized. That's really one of the key points about this. So instead of having this idea of, hey, I just create all my own things, what I really want, ideally, is for some other party, again, if we think about this idea of what we had in the real world, but some other trusted party, some issuer, would be able to populate something with claims about me, give it to me, and I would store it. I would store it in this whole same idea of a digital wallet, so it conforms to certain standards, and then I could present this to them, and there would be some way they can verify without having to have a direct relationship to say, oh, actually, yeah, this is good. I'm going to trust this. I'm going to enable this to work. Now, when I think about this type of verifiable credential, think about the parties involved in this. The issuer, well, this company still has the right to issuance. They have the risk because they're making claims about you. So they want to be confident about that. What I disclose though, so the claims in this, what I disclose and who I disclose to, that should be my decision. So the issuer, hey, they make the claims about me and give me, and that's the key point, me, the subject or at least the controller of that identifier, it goes to me, and then I have the control of who I deem I want to present that to. Now, there's even things around the idea that maybe it's selective disclosure. I don't want to give the whole set of claims to someone. Maybe you just want one claim out of that. Or maybe it's zero proof. So I have zero knowledge proof. I want to be able to attest to this party, hey, I'm over 21, but I don't want to share my birth date with them. And those things get very difficult when we start talking about computers and signing things and proof because of the way this is all going to work, and we'll see that. But they're challenges that are being looked at. They're challenges that are being worked on. So over time, I think we're going to get these. Today, there's not, I don't think, a standard way about that selective disclosure or that zero knowledge proof, but they're things being worked on. But think how interesting that is. Hey, yes, I have my COVID vaccine, but I don't have to share details beyond that that maybe could then track other things I'm doing. So there's a lot of real world ideas that really come into play here. Who's in the center? It's not the identity provider anymore. Well, it's not an external central identity provider anymore. It's me as the user, the controller of this. That's the huge shift. So when you think about this model here, so I can think about this is centralized identity. In these models, I'm shifting to a decentralized. There is no external IDP in this picture. When we start talking about verifiable credentials and all of these concepts, this is the key point. The controller of these identifiers, I have control. I hold the verifiable credentials. I choose who I want to give them out about. So if we really break it down, there's a series of different trusts that have to occur. So remember me, I'm the holder. So I'm going to hold these credentials that are going to be given to me. Then we have the idea of this issuer. So then there's the issuer. And then there's going to be this verifier. Now, the whole point in the decentralization, I don't want there to have to be a direct relationship between the issuer and the verifier. It's all kind of going through me. Now, before the issuer is going to give me a verifiable credential, well, they have to trust me. They're not just going to make claims and give it to me without some proof. They could be giving PII in this verifiable credential. So there very well could be some pre-step that I've logged into a site. Maybe there's some in-person meeting. I'm going to an office. I'm doing something to really give certain levels of proof. Now, the levels of trust is going to depend on how important this credential is. If it's a government ID, I want a lot of trust. That issuer has to really know that is me. If it's a pizza frequent buyer card, they don't care at all. I have to then trust the verifier to give them, to present these credentials I'm going to get. But also the verifier has to trust the issuer in some indirect way. Because I have to know, hey, these claims they're creating really came from those and they've not been tampered with. So what we have to have is this idea of some kind of verifiable data registry. And what's going to have to happen is I'm going to, as the issuer, write some cryptographic material that I can then sign things with, and we're going to talk about this, that the verifier could then read whatever that gets written, or the verifier could then read that and use it as part of that all up. And what that essentially enables to happen is indirectly, the verifier can now trust things coming from the issuer. So we have these different sets of things that have to come into play, and this all gets fairly complicated. And the reality is, when I use verifiable credentials, I don't need to know any of this. It's just nice to understand some of the things that are happening behind the scenes to really make all of this work, because this is key. We have to break this down and understand all of these components to have trust that I want to use this, that I as an individual want to use this, I as a company want to use this. So it's really important to understand how this really can all work together. So I keep using the word proof. I have to be able to prove, and I have to feel confident that these things that are being given to me really came from the issuer and have not been tampered with in some way. Now remember, in the real world, how did we do that proof? Well, the real world proof was, hey, there's funny holograms in things. And my original Microsoft certified card has a hologram on it. My driving license has hologram things and watermark things. There's a huge market for falsified official documents because, hey, they're certifying some fairly important things. So in the digital world, I need to be able to do the same thing. I need to be able to prove. So in the real world, how do we prove things? Well, this is not a new problem, and we've had the solution for a really, really long time. And I do actually, so as I wrote these different terms, I should note in the terminology we have been using, remember, this is the holder. The person holding these credentials, I'm the holder, this was the issuer, and this is the verifier. So there's three key roles involved in all of this. So let's think, how could this actually work? So I want to issue something. So I'm the issuer. I want to be able to create some digital thing, say verifiable credential, that can be authenticated and proved that it really did come from me, and it's not been tampered with. I have some payload that needs proof. Well, in computers, we use cryptography. That's really the key part of everything we do. And so what we use is asymmetric encryption or public key encryption. So as the issuer here, I have a private key and I also have a public key. Now the key point around these private public keys is, if I think about what's shared, the private key is never shared. I keep hold of that private key above all else. I have to keep that secure. Because what we're going to be able to do is to prove ownership of things. Well, I can do certain cryptographic operations on a payload using my private key that the public key could decode, and assuming it's the same value, well, it proves I had the private key. And so by having the control of the private key, I prove, hey, I am whatever entity is related to this. So the people I wish to communicate with have access to this public key. Now the way we essentially use this is I have a certain payload. So what I'm going to do is there's some payload. And in this case, what we're really talking about are claims. I want to make claims about something. And then what we can do is I can generate a hash. So a hash is just a mathematical operation that's guaranteed to produce the same hash value if it's the same input. So guaranteed, hey, if this input goes in, it will always generate the same hash value. So I create these claims in a certain format. I generate the hash value. And then what I can do is with my private key, I can encrypt that hash. So I can take that hash value, encrypt it with my private key, and that becomes my signature. Because I'm encrypting it. I'm encrypting the hash with my private key. So at this point, if I just looked at those things, this is the proof. So I attach this to the overall document. So now my document becomes this. And the signature is the proof that, hey, it really came from this issuer because only this issuer has the private key. And I can prove it's not been tampered with because when they receive it, well, they can decrypt this. So if I now think of this picture in the issuer, well, now if we have over here the verifier, well, I send this to them. I send this payload to the verifier. And what they can do is they can run the body of the work through the same mathematical. They will get a hash value. So they will calculate the hash. And then all they have to do is take this signature block. So they take the signature block, and with the public key, so if they take the signature, so if they take my signature, and then they decrypt it with what I publish as my public key, decrypt. As long as they're equal, as long as that result of the decrypted signature equals the hash they generate, they know it came from me. They know it's not been tampered with, because if it had been tampered with the content, it would be a different hash. It would prove it's been tampered with. So through this is how I can do cryptographic proof that, hey, it really came from this issuer because only they control the private key and it's not been tampered with. So this is how in computers we do proof of things. So that's fair, but there's a huge problem with public key cryptography. How does the verifier know that that's the right public key for that issuer? Especially in a decentralized world. How do I know that is the public key for the issuer? That's a huge problem with this. The way we solve it in regular PKI is we have high-level certificate authorities that everyone trusts, and they sign things on behalf of companies who do some out-of-band or whatever trust with them. So it's an external central party is certifying, yes, this is the public key for this issuer, and I trust that higher-up certificate authority. But that will be centralized. I don't want to do that. I want a decentralized model. And so I have to have some way to accomplish this. How do I, as the verifier, know, and here's the true problem, that's correct? I need to know that it's really this issuer and this is the right public key. So how do we solve that? I have to have some kind of identifier, and I have to have some way to tie the identifier to the public key that they can look up. So I need some identifier that they could resolve to find a public key and have strong confidence that it's the right one. So how do we do this? Well, I need an identifier. I need some set of identifiers. Again, there were things like X.500 names, there were DNS names, there's URLs, there's different types of identifier out there in the world. But we're going to have a new type. So we're going to have this idea of a DID. A decentralized identifier. It is identifier, not identity. So it's a decentralized identifier. And this is not just people. Yes, people would want a decentralized identifier, but organization, my pets, my kids, maybe a building. Many different types of real-world entity will want decentralized identifiers. And sometimes the controller will be the same as the entity of that decentralized identifier. I, as an adult, hey, I will be the controller of my decentralized identity. But for my kids, I would be the controller for them. For my pets and their vaccination records, I would be the controller for their decentralized identity. But if I think about this decentralized identity, remember we're coming at this brand new set of requirements we want. What are those requirements that I want in this brand new type of decentralized identifier? What needs to be some core fundamentals to make this workable? It needs to be permanent. It never needs to change. Potentially, I might want a different identifier in the future. Maybe I might have actual multiple identifiers. There could still be concerns I have about parties tracking my use for the same identifier, but it's my choice. But the key thing is, it never needs to change. It needs to be resolvable. Because think about what I have to be able to do. I have an identifier, but I need to be able to find the public key and maybe other things, other ways to communicate with me. So I need to be able to resolve it to some kind of metadata. That's a key point. I need it to be cryptographically verifiable. It's a long word. So cryptographically verifiable. I need to be able to prove I'm in control of that identifier. I don't want someone else to be able to use it. So there has to be a way using these public and private keys that if I am the controller of that identifier, and I would be the controller because only I would have the private key, I can prove it. So through some cryptographic operation, using those cryptographic materials, I can prove it. And it must be decentralized. I don't want some central party giving these things out. There's no central registration authority that allocates these. Now, once again, just to use verifiable credentials, you don't need to care about any of this. But I do think to get confidence in this and its workings, it's nice to understand what's kind of happening behind the scenes to actually be able to use this. So those are our requirements. I must have these things. So we're going to have this new decentralized identifier that we know fundamentally has to be able to tie to some public and private keys. So let's think about that for a second. So I'm going to have my did. And there's really going to be two sets of worlds I could think about for a second. There's going to be stuff that I share, so on this side of the line, and then stuff I'm not willing to share. It's going to be a very important point of what we talk about. Now, we already know when I think about this distributed identifier, there's going to be someone in control of it. It might be the holder, the entity that this decentralized identifier is in the real world. So there's going to be this idea of my controller. And then we know we're going to have these public and private keys. So then we have the idea of, okay, great, there's the public key. And then we know there's going to be the private key. And actually, I should make sure I draw this on the right side. So that the did, actually, I'm going to move this line. This shared, the did can be shared. I'm going to actually draw the line over there. So this is the split. My did and my public key, obviously I'm going to be willing to share those things. The controller, no, not necessarily. And the private key, definitely not at all. Now think about the various bindings we might have. The private key and the public key are bound together. They are mathematically bound together. There's no splitting those things up. Only the controller knows the private key. So they're the things that just where we are right now. Verifiers can know the public key, verifiers can know the did. But now what I need is for those verifiers, well, I need them to know this identifier uses a specific public key, because only if the verifier knows, well, this identifier uses this public key, can I prove I am the identifier because I have the private key, and I could respond to various challenges. Hey, sign this, not used more than once with the private key. I can do that. Well, that proves I have the private key, which proves I am this identity. How do I do this? And this is the really tricky part. So how do I have the identifier bound to the controller? So I want to be able to prove this. I want these bound. And then what I also need is how do I have the identifier bound to the public key? I need to solve these two problems. Once I can solve that, I'm good to go. Now, as we talked about with regular PKI, they solve this by certificate authorities. There's a high level set of certificate authorities that can sign things that will basically, with their private keys, sign digital certificates that are your keys and the public keys, and I can have an X.500 500 name or DNS name, whatever that might be. They're providing that proof. But I don't want that. I don't want any central authority. So what I need to be able to do is use that same cryptography that is used to bind these public-private keys together. My solution needs the DID, that decentralized identifier, to be generated. From the public key. If the public key generates the distributed identifier, they're mathematically bound together. As long as I trust math, I'm good to go. There's nothing that could actually break that. And if mathematically the public key is now bound to the decentralized identifier, well, if I'm the controller, if these two things are bound together, I can prove I'm the controller of this decentralized identifier because only I have access to the private key, so I can respond to challenges for the corresponding private key to the public key that's bound to the decentralized identifier, so I can prove that as well. So that's the solution. We're done. I use math and cryptography to generate that decentralized identifier from the public key. So I can self-generate private public keys. Anyone can do that. I use an algorithm to, from the public key, generate the decentralized identifier. That's just math. I have the private key. I can prove all of these things. Well, I'm not quite done because there's a problem. What are some of those key features of that decentralized identifier I wanted? Permanent. What's one of the good practices we want with public-private keys? Oh, I want to be able to rotate them. Well, that's a problem because right now, my decentralized identifier was generated from the public key. So if I think about versionings, okay, private key 1, public key 1, I'm happy at this point. But now I have to do a key rotation. So now, it's been 6 months or whatever that might be, I need to rotate the keys. So now I get a new private key and a new public key. That doesn't work anymore. I have to change my decentralized identifier every single time I do a key rotation. I don't want that. So what I need is a way for initially the genesis. So the first public-private key, and when it's the public key, that genesis, the first public key, yes, that can mathematically be bound to the decentralized identifier. But then I need a way that after that, I can rotate the key, but have some trusted means to go back through history and say, oh, well, from the genesis, that first one, yes, that did mathematically tie to this decentralized identifier. So yes, even though the keys have rotated, I'm still good to go. Now, one of the requirements we had also, remember, was resolvable to metadata. And this is why we need that. Because I can't long-term rely on math to just say, hey, this public key mathematically ties in through cryptography to the decentralized identifier, because it won't. As soon as I rotate the keys, I've broken that link between them. This is where we have something called the DID document. And this is what the DID will resolve to. So now we add in this layer of, what color should we use? We use orange. Now we have the idea of DID documents. And what the did document is going to contain, well, contains the public key. And the key point is the did can always resolve to the did document. In fact, I shouldn't even draw the arrow there because as we're going to see, there's going to be different versions. Really what it always resolves to the did document of that did. But over time, it's going to change. Now, that metadata I've said is the public key. That's probably the most important part. But there are other things. It could have things like service endpoints. A service endpoint could be some address that if I was receiving this, maybe I can go and communicate to get maybe other information, some ongoing set of requirements, some interactions. Imagine the issuer was a university and they give me a certain type of verified credential we're going to talk about. But as the receiver, the verifier, I'm like, well, how do I know you're a legitimate university? Through the service endpoint, I'd have a way to communicate with you. I could say, hey, give me your official government university sanctioned ID. They could give it to me, and then I could go and do various checks on that. So I can also have things like these service endpoints as part of that metadata. So I can have other things. But the key point now is, so this did document, well, initially I signed it with the private key. So remember that proof? So it's signed with the private key 1. I now rotate my key. I update my did document. But my did document now, actually I'll change the color, now has public key 2. But how do I establish that chain of trust? Well, I sign it still with private key 1. Oh, okay. So now there's this chain that can actually go back. And then if I rotate it again, well, the next did document with public key 3, well, I would sign with the private key 2. So I can always go through the chain of trust if needed, or it will be needed. I can go all the way back through the various chains over time. Say now I've got public key 3, but I would have signed it with private key 2. There's a link. I can look at this did document and I can validate all the way back to, hey, now it cryptographically would resolve to that initial one. And that's really the important point when I think about the whole point. It has to be resolvable. The reason the did has to be resolvable is I want to be able to rotate the keys. I mean, it really boils down to that. Something where I couldn't rotate the key is actually pretty useless. If I think of any kind of public key cryptography, things get broken over time. I have to be able to rotate the key. So yes, initially, the identifier mathematically, cryptographically is tied to the first public-private key, or the public key. But by being able to resolve to this did document, it lets me update the public key so I can rotate the keys. But through this chain, I can still go back and validate, oh yes, it does tie into this. Now, it gets more complicated than this. And in some ways it gets simpler than this because I really don't have to care about these things. The whole point of this did is that, hey, it is resolvable. It's cryptographically verifiable. It is decentralized. It is permanent. But these things are going to be taken care for me. This is not something I'm actually going to have to manually go and worry about. So if we think about what is a did, let's break it down into a bit more detail. A did, it's a URI, which means just like HTTP, send to, mail to, whatever that might be. Well, it starts with did, colon. So HTTP, colon, did, colon. And then we're going to have a method. And there are many different methods. This is an open standard. there's going to be different methods to be able to facilitate this decentralized, this resolution, this cryptographically verifiable. There's different ways we can anchor and trust in this. But then whatever the method is, there is some unique identifier within that method. It's guaranteed to be unique within that specific method. Now, remember that did represent some specific entity, some specific subject, something in the real world, me, a company, my dog, my kids, whatever that might be. And we can actually go and look at the spec. So if we look at the spec, so the specs are actually fantastic. Sometimes you go, oh, spec, yuck. So this is talking, for example, about did syntax. And so it's got method syntax. So a method must have exactly one, but you can say, hey, the specific ID must be unique within the did method. Maybe it's globally unique as well. To reduce the chances, so there's a whole set of different things I have to do to make this happen. But the key part is a did is really just resolving to a did document. That's fundamentally the point, is the did is going to be able to resolve to a did document in a secure, trusted way. That's the ultimate goal of all this. I want it to be able to resolve to that did document because that's what's got the metadata, the public key, and those other things I want. I have the controller. The controller is the one that can make changes to the did document. They can update those keys. They have the private key. They also, a lot of times in our scenarios, the controller will be the same as the subject, who is the same as the holder. They're all going to be the same thing. So the did and the did document are very, very tightly coupled together. But there are a huge number of methods. If we go and look right now, so let's look at the current methods. And these are, I don't even think are all of them. But if we look at the did methods available to us, there's a lot. Now, one of the things you've probably heard about decentralized identifiers and decentralized identity is Bitcoin and blockchain. And absolutely, there are methods that use those. You can see here, look, Bitcoin. Okay, I can go and look at the Bitcoin method. And if we look at the Bitcoin format, that unique identifier part is basically by nature of, hey, I'm writing some transaction, and those transaction identifiers will become part of that did. So it goes through the entire spec of what it's doing, but what you're going to end up with is a did. Notice the method is BTCR for Bitcoin. And then it's going to have something based on some transaction that it made to the blockchain. It could be a smart contract address. There's many different methods available to us. There's things that don't use blockchain. Maybe it's based on a web address. There are many things. There are ones that are layered approaches, where maybe, hey, the method initially writes to some interplanetary file system like ION. Interplanetary, there's copies of your data on Mars, which then takes the hash of the write to the interplanetary file system, batches them up, so I can have thousands in one transaction, which then does a Bitcoin to the blockchain to really anchor it so it's immutable, so it can never be changed. So some of them are multiple layers to enable this functionality, because there's different things I think about for those methods, because they have different environmental impact. They have different levels of trust. They have different levels of cost, of performance, of scalability. So there's not one method, because different organizations' priorities and goals will differ. And so these different methods use, as the name suggests, different ways and methods under the covers to achieve these things, to make this identifier permanent, to make it resolvable to the did document, to make it cryptographically verifiable and make it decentralized. But there's different ways you can achieve that. But they all, doesn't matter what the method is, resolves to a did document. And that's really the key part. Some of them are doing proof of work, some are proof of stake, some are proof of, hey, I own this domain. It really doesn't matter. There's some Genesis public key, some Genesis transaction that's rooted in something we trust that I can then build off of. And we can look at some examples. If we look at some of these, so there is key. So if we look at the key method, well, it's exactly what the name says. The unique identifier is the public key. So that's that most pure form we talked about. But if we actually go and look at some of the security and privacy considerations, what don't we like about this? Key rotation is not supported. Because it's purely generative method, you can't change the key. Well, that's really not very useful. And so the ultimate result is long-term use is discouraged. Now, if you had some short-term use, maybe it's fine. I don't need to rotate the key. So this becomes super, super simple in a way. I could do this. But because I can't rotate it, I'm not going to use that long term. We already saw the Bitcoin. There's a web method. So if I think as an organization, I already own a domain name. I already have an SSL certificate. So what I can actually do, my method to resolve to my did document, I can actually just root in my domain name. And this is actually very attractive for a lot of organizations. I'm using this for mine. I could actually go, and if I look at my service I'm offering, this is my did document. So if I look at my did, well, my did is did web. And it's just by nature that I own onboard to azure.com. And what I can do is there are certain well-known locations that I have to be able to place a document on. So in this case, the way this works is it has to be present in .well-known, and the did document has to be called did.json. So as an organization, this isn't using blockchain. This is simply, I as a company already own this domain. What is the goal of this? I need to be able to securely share my public key and prove it really is tied to my identifier and prove that I'm the controller of it. Well, it's got my domain name in it. So it's got my domain name in it. I'm hosting it under my domain, so my identifier actually becomes my domain. And within here, you can actually see I've got my cryptographic material. So my verification method, I'm telling it the key I'm going to use. I can have different versions. I tell it the type of key, and then I actually have the keys. So I'm making my did document available just through the web. That meets my requirements. I'm totally good with doing this approach. So again, the key point in all of this is, hey, look, yeah, I can see I've got my did is within the document. I can see the verification method. I can see my ID. And then I can see the type. And I can even actually go and see the keys. So all of that is just there in. So that's one option, that's one method. So as a company, that's pretty attractive to me. There's things like Ion. So Ion is another big one, Microsoft, in its services. So there's a huge number of options you have here, but Microsoft is really focusing on web and Ion right now. And Ion is actually built on top of the sidetree protocol. So if I go and look at the sidetree protocol, it shows me those layers. So yes, initially, I go and communicate with an Ion node, which goes and writes something, maybe a database, which then writes to this interplanetary file system. When I do the write, I get a hash value. I batch those hash values up, and then I write it to a decentralized ledger like Bitcoin. By writing it to the ledger, it becomes immutable. So I can track back, okay, the hash value is written to this Bitcoin transaction which cannot be changed. So I can go back and get those different levels of trust. And because it's batching them up, it's not some Bitcoin transaction every time I do anything, which again, we think about the environment. we think about the impact of these methods. That's one of our considerations. It's like, well, okay, if I wrote to a blockchain every time it's a proof of work, I'm heating up the planet. So one of the benefits of Ion and the layers, it batches up maybe thousands of those interplanetary file system hashes and just does a transaction. So there's still a proof of work there, but it's not per action I'm doing. But some of them, like the web, doesn't use it at all. Go and look at the specs. They're pretty cool, but as an organization, I can pick, and it doesn't matter. And that's going to be one of the key things we're going to see. It doesn't matter which one any particular company uses. The way I resolve it is going to be exactly the same. I don't have to care. I don't have to do different things if, oh, they used Ion, they used Bitcoin, they use web, it's the same thing. Doesn't matter what I do. It's all abstracted from me. And if you look at the specs, the key point of all of this is whatever the method, I give it a did, it has to respond to a did document. It has to be able to create. It has to be able to resolve and then be able to read it. I have to be able to update and I have to be able to deactivate. So those CRUD operations, that's the key point of the methods. And again, as the verifier, I do not care at all. I really don't care what particular method they use. It's transparent to me. I'm going to use this ability to resolve it that takes care of whatever method they happen to use. So there's a lot. Ultimately, a couple of them will bubble up and become the most used. So right now, I think there's 100 odd. There'll probably be a few key ones. So I think web will probably be very popular. Things like this Ion will be popular. The ones where it's a certain maybe Bitcoin transaction for every one, there's probably be some issues, but go and take a look. It will evolve over time. Now, one thing you probably noticed when you looked at the Bitcoin one or the key one, and most of them, if it's using Ethereum, it's a smart contract. They're really hard to read. Only that web one is actually fairly friendly because it's a domain name. So as a human being, when I go and look at a did, it's ugh. It's horrible. It hurts my brain. Why? Why are the dids so ugly? And it turns out, like most things in life, I can pick 2 out of 3 things. I can have it done fast. I can have it done cheap. I can have it done right. Pick any 2. Well, in this case, I can have it human meaningful. I can have it decentralized. Or I can have it secure. Pick 2. I mean, that's what really matters. This, tough. Can't have it. So we pick 2, we pick the 2 that really matter. I am not going to see these dids. To all intents and purposes, I'm never going to see them anyway. The point is it needs to be decentralized, it needs to be secure. Technically, you can cure all 3, but it's very hard to do, and there's just no point. So this is the whole idea. Now, I'm 2/3 of the way probably through this presentation, and I've still not really talked about a verifiable credential. I probably should fix that. But it builds on this. The whole point is we need these decentralized identifiers, and we need to be able to prove that, hey, we are, or it was issued by, really, this particular decentralized identifier, to be able to issue any verifiable credentials that have claims that are meaningful. So this part is really, really important to all of this. So when we come to why have we spent so much time on this, it really boils down to the fact that, well, I have some controller that controller, remember, they own and keep secure their private key. What they're making available? Well, they're going to make a did document available. So there's going to be some ability to have a did universal resolver. Doesn't matter what the method, I'm going to be able to go and query this did resolver, and it's going to give me back, when I give it a did document. And that did document is going to have the corresponding public key. And the key part is, even if the part of the method, and this is where the trust comes in, even if I rotated the key, that underlying method, when it resolves, is resolving that in a trusted, cryptographically verifiable way. That I know, hey, this really is the did document for this particular decentralized identity. So now what I can do as a controller is, hey, I can create something. I can say, hey, the issuer is me. This is my did. And I can make a bunch of claims. I can use my private key to sign it. Remember, I take the message hash, sign it with my private key, attach it. I can now give it to a verifier. The verifier can look inside and see, oh, it was issued by this did. Hey, I'll go to my universal verifier, whose whole job is to resolve that to the did document, which I can now read. Oh, hey, that public key, I'm going to use that to decrypt the signature. I'm going to generate my own hash. Hey, they match. Important point, we're done. So this is the whole key part. This is what we've now allowed. Through the did and the did document, without any direct communication, remember, it's just whatever method, be it the Bitcoin or key or web, whatever that is, doesn't matter. This did resolver, I can write my own. There's ones out there. Again, it's a standard. There's a spec for this. Whatever the method, this one resolver will ultimately give me the did document in a cryptographically provable, trusted way. That's what all of this boils down to. So let's actually think about a verifiable credential in practice. How would this actually work? So we have to start off with, again, this idea of the issuer. So I have the issuer. Remember, the whole point of the issuer has their own did. And I guess we'll draw down the bottom this idea. We'll do it in the universal pen. We have some trust system. Whatever one that is, I do not care, be it blockchain or ion or web, I do not care at all. But there's some underlying trust system that fundamentally what this is going to give me is this did is anchored in that trust system. And what it's ultimately going to be able to give me is their public key through that did document and maybe service endpoints and all that other stuff. But all of this gets wrapped up in this nice did document. So in a trusted way, I'm going to be able to take this issuer's did and get their did document. Fantastic. Now, we also have a holder. We've not really spoke much about the holder, but the holder is me. I actually want to get these verifiable credentials and then be able to give them to various people. So I want to be able to request from the issuer a verifiable credential. Now, to be able to do this, the first thing I need is, obviously I've got my device, a phone, a computer, whatever that is. On that device, so I'll draw a little box around this, I've got some kind of user agent. Think of it as a wallet. Now, in the Microsoft world, for an example, it doesn't have to be at all, but this could be the Authenticator app. So I open up the Authenticator app. Initially, my Authenticator app has nothing on it at all, and I'll walk through this in a second. It doesn't have a did of its own. It has nothing initially. The first time I actually go to request, hey, I would like a verifiable credential, please, it springs to life. So what it's going to do is it's going to go and create my private key that it's going to store in a secure enclave. So that's my private key. Obviously, it's also going to then generate a public key that's paired with that. And then it has to create that decentralized identifier. Now, the way we're doing this is ion. Remember, there's different methods available. And so it's going to generate my did. Now, I didn't go into the detail of it, but if you actually go back and look at this ion spec for a second, there's something interesting about ion. We can see, if I can actually find it, it talks about different structures of its actual did. And one of the interesting things we have is, remember, this is multi-layered. I'm trying to find the structure. There we go. File structures. Let's have a look. Let's see if I can find it. Remember, it's those multiple layers. So you have this idea of, hey, it goes to some database, and then it goes to some interplanetary file system, and then eventually it goes to a ledger. So if you think about those layers, there's time involved in that. It's not going to instantly, especially if it's batching up those various hashes, it wouldn't instantly be available. So one of the things it does is its format is you have this short form did. So now this is side tree, but again, ion is built on side tree. Did side tree, and then this short form URI. Great. But it also generates a long form did because there is a period of time between the generation of a did and it properly being anchored, etc. And so the long form did, well, the long form did actually contains the did document, which actually contains the public key. And again, this is a huge amount of detail you really don't need to know, but it's important to understand. So this is what Authenticator is doing. It's using ion, but it's using the ion long form. And what that means is it doesn't actually have to really anchor it in interplanetary file system or Bitcoin ledger or anything else. It's using the long form. So it did actually contains the did document, which contains the public key. Because really for this identifier, this is just my wallet in a way. I want to be able to generate a decentralized identifier for me. But what's going to count is not what I say about myself. No one cares. It's going to be what other people say about me. So the whole point is now I've got this identifier that contains that public key as part of it. It is not published to any ledger. It's just bound to me as that subject. And if I give this to someone, they can still run it through the resolver. The resolver will try to get a newer version of the did document. If it doesn't work or it can't find it, then it will just use the version that's in that encoded long form state. So now I have a single did in my wallet that represents me. Okay, so now I'm requesting a verifiable credential. As part of the protocol that goes through this, as part of the protocol of issuance, it's going to request me to sign something with my private key, and my did will be included in that signed payload. The JSON web token, the JOT, will have that in it. Now, important thing, when I'm doing this request, remember, they might want some evidence. This did really is this real world identity, this real world entity of John Saville or this company or this dog or whatever. So it might be as part of the request, I have to give it a verified credential I already had from someone they trust. Or I've had to go to a site where I've had to authenticate first, which then lets me go and do this request. Or I'm standing in an office. So there might be an idea of a bootstrapping to get the initial set of permissions. But let's say in this case, this is the first one. So maybe I have done some other authentication through some other method that's going to allow them to trust to say, hey, okay, the did is John Saville. I'm going to give them some credential. So I may have to go and log on first to then go and request this. So now what they will do, remember this, their did is anchored in that trust chain. So I'm requesting a verifiable credential. So they are now going to go and create one. They're going to create a verifiable credential for John. Well, for that decentralized identifier, more specifically. They're going to say the issuer, well, is them. the subject, so who this is about, well, that's this did. In this case, and in many cases, the subject and the holder and the controller of this did are all the same thing. Again, it could be different. The controller could be a parent or the owner of a pet or the owner of a building. But let's say this is for me as a person, the holder, the controller, did the subject, all the same thing. And then they make a bunch of claims about me. I was a citizen, he earns this amount, he was born on this date, whatever. Remember, they have their private key. So then as the proof, they sign it. And they give it to me. And at this point, I store it in my wallet. So it's just stored in my wallet. Okay, great. So it's stored. Important point. This verifiable credential is not written to some ledger somewhere. This might have PII in it. The only place this is stored is my wallet. This is not stored on a ledger. It's not stored on a site. I don't want that. It's got PII in it. This is generated. The proof is anchored in some trust system, but the verifiable credential itself is not. It's given to me. I store it in my wallet. Now, there is a long-term concept, maybe of an identity hub, where instead of this just being in my local wallet, there could be some cloud-based service that's secure where I could store these and share them between different things. But those things are all being built up. You have to think over time, when this takes off, I'm going to have a lot of verifiable credentials. Okay, so now I want to use it. I want to use it with a verifier, whoever that may be. I'm going to get a presentation request via OIDC SIOP. So OpenID Connect is highly used already. What they have done is there's an additional spec built on this, so I can still use OpenID Connect. So most of the web already speaks OpenID Connect. The protocol I'm talking to leverage this is just a modification of that. And there's going to be a challenge to, hey, sign something with my private key that matches the public key found in the resolution of my did. So what's going to happen is they're going to have a request. So this verifier has some request. And now what I've got, remember, I've got this verifiable credential. So I've got it in my wallet. And I might want to send it multiple verifiable credentials. But remember, the issuer, the point here is their did, and the subject was my did, and it's got a bunch of claims about me, and then they signed it. Great. I might put multiple virtual credentials in one verifiable presentation. So I am now going to create, what happened there? A verifiable presentation in response. I am going to sign it, and then I send it to them. One or more verifiable credentials. I'm packaging them together in a verifiable presentation. I'm signing it with my private key and sending it to them. Now at this point, as the verifier, I'm like, well, okay, I need to look those things up. So how do I do this? Well, we have the did resolver. They can be using different methods. This did could be web. This did could be ion. They do not care. They don't even have to look at what the method is of the did. All they're going to do is they're going to say, okay, wrong color. Why did that not change? They're going to say, hey, what I need to know, I need the did documents for, well, there's two dids, right? I want to know the holder did. And I also need it for the issuer did. Too many colors. And it's the resolver's job to go to whatever trust system that method particularly uses. I don't need to care. But what it will ultimately return to me are the documents. It's going to return me the did documents, which are going to have the public keys of each of the entities. And then with those public keys, I can validate. I can say, okay, that's good. The did in the verifiable credential does match the did of the person presenting it to me, so it's really them. Okay, this credential is for this holder. And it really did come from this issuer because I can validate the signature on it matches that one through the trust system. I'm happy. So the end result is we're done. They never spoke directly. I have complete control. When they sent the request, I'm prompted for, hey, what do you want to share? I get to pick which verifiable credentials in my wallet I want to share with that verifier. And again, in the future, the path will kind of evolve to maybe it's selective presentation. Maybe only show one claim out of this. Maybe it's zero knowledge proof. Yes, I'm employed by a company without having to send you the actual, so it will prove it without having to send the verified credential directly. This has got too much information. I don't want to share my salary or my start date with you. I just need to prove I am employed. So those things are all coming. So what does this really look like? And again, in the real world, I would start off with an empty wallet. And often I have to bootstrap my wallet initially in the real world with something from the government, for example. So I get some government ID, and then once I've got a government ID, I can then show it to other issuers, so I can then go and get important things like, an employment card that I can put in my wallet. I can get other important things like my Blockbuster video card. But that's the process I would go through. So if we think about that same process, let's do exactly the same thing. So I want to bring up, let's just open this up over here. Let's switch over. So here is my Authenticator app. And right now you can see it's completely empty. So what I could do is I could jump over to a site. Now let's assume I've already authenticated to this site. Let's actually move this over for a second. So I've already authenticated to this site. And I enter in my name, blah, blah, blah. Maybe I have to upload a picture. This is a true identity. I verified it. I go through some set of processes. I upload a picture of myself. I maybe have to upload some other government ID. Again, it's all about that bootstrapping initially. But it's verifying my information. It's doing checks. And what it's going to end up is it's going to give me a verifiable credential. So it's now added that to my wallet. I now have a verifiable credential from True Identity. In my wallet, I can go and look at it. I can see, oh yeah, it's my name. I can see the issuance. I can see expiration. I now have an identity. Well, if I now carry on with that life, I can now maybe go back to my next stage. Okay, I've identified my identity. Now I want to get a work card. So it's asking me, hey, can you share your kind of true identity? So I want to share. And now it's telling me, hey, the company is asking to see this verifiable credential. Do you want to share this? I'll say, sure. I'm going to share it with them. It was approved. And now I can go back, continue onboarding. And now I could retrieve my verified ID for my company. Yep, I'll add that as well. Oh, okay, fantastic. So now I've got another identity. And if I went back and looked at my initial, I can see how it was used. I say, oh yeah, I used this verifiable credential and I actually shared it with, this other company. And you can set up your own ones. So a little bit of fun just while we're doing this. So onboard to Azure, super follower credential. I could say, hey, I want to get a credential. And it's going to show me a code. Now, it also could have linked directly, for example. But what I'll do now is actually, let's just open up so you can see this again. I'll go back to my site. I want to add a new one. We'll add in that code. It has a PIN, so I'm entering in that PIN. And now I've got another verified ID. Oh yes, please. Onboard to Azure Super Follower. Very useful credential. So now I have yet another credential in my environment. Now the way this was, and again, this is open standards. The way I've done this is I'm using Entra. So that little silly super follower, I'm using the verified ID functionality of Entra. It took really a few minutes to get stood up. Now, by default, it's using web. So what it would basically give me is it generated the public private key. The private key it stores in Azure Key Vault. It gave me this document and it told me, hey, make this available on that website you own in this folder and it needs this name. So then it went and checked I put it where it was. Because I'm using web, it's a little bit funny, but you also have to prove domain ownership. So then it gives you another file that you have to put in another well-known location that basically just says, hey, here's the linked did that I'm actually using for that domain. And that was it. And then you just go and create your credentials. So I created an onboard to Azure super follower, and you can see the credential preview. You can modify the look, the feel, the logos, all of these different things around it. And then you just write a little app to issue. You write an app to verify. There's samples on the portal for how you do this. But it's actually very easy to get up and running with. So one of the key things is if you want to go and start trying this stuff out, you absolutely can. The sample you can just download and there's samples in different languages. You can go and use these things. An entry is just one example of a service that helps you be an issuer and helps you be a verifier. But it's going to interoperate with whatever service you use for that issue. You could write your own. You absolutely could. It's just, hey, there are things that are out there that help you do it. Now, with all of this, well, one question that comes up, what if I lose my wallet? What if I lost that app? And as I mentioned, there are things, for example, in Authenticator you can back up. So ways to protect that. There are, I think, things in the future around webs, where you can actually have an identity hub, where I could then share it between different devices. But ultimately, if I lost my wallet, the same way if I lost my physical wallet, I had to start again. I'd have to start fresh. So I maybe have to go and request a verifiable credential from some government agency to put in my digital wallet. Then I'd have to go and request my employee. So just like a physical wallet, if I lost, I can start again. It's a pain, and it will be painful in the digital world as well. But you could do it, and that's what would be required for that. Now, ultimately, why do I care? Like, why do I want this? Now, we did talk about, well, the centralized, there's a lot of challenges with not owning my identity, both as a company, both as a user. So this decentralized approach is benefits to everyone. It's benefits for issuers, it's benefits for the holders, it's benefits for the verifiers. Everyone gets better security, better privacy, better protection, better portability. They're all standards. So suddenly I'm not worrying about some particular implementation that this person has done. It doesn't matter. Remember, as long as they're following the standard, the DID follows the standard. The DID method they choose is one of the standards. Well, that DID verifier is going to work, the DID resolver, which is going to give them the DID document, which is going to give me all of this proof. The method you choose, they all have different considerations. Hey, the environmental impact, if it's maybe proof of work. Maybe it's proof of stake, well then it costs me money. There's different options there. I'm going to pick the one that best aligns with my principles, maybe around, hey, that environmental impact based around its trust status, based around the security, based around the stability, based around the scalability. I have choices. As an organization, I'm going to look at those things. But everyone gets benefits when I think about that idea of, hey, the security, the privacy, the protection, the portability, the control. As a company, well, when I suddenly can support these verifiable credentials, I now have less concerns about storing people's personal data. I don't want to store that GDPR. Then I have to somehow prove and give it away. If there was a breach, I've got all this stuff. Well, in this world, hey, give me your verifiable credential that proves you're over 21. Give me this verifiable credential that proves you've had a COVID shot, that proves you're employed, that proves you're a citizen. I don't have to store it. Next time you do some other interaction, I just request it again. It's a verifiable credential. It's super, super easy to do those things. So I want some way to identify my customers. Super, super easy. The wallets have standard features, which makes interoperability really easy. Hey, maybe it's an NFC. Maybe it's just, hey, some scanning thing. Whatever it is, there's standards around that. Hey, I buy something. Hey, they issue you a verifiable credential. You go and take it to the fulfillment, and they give it to you. It could be a train pass, a concert ticket. It's going to help reduce fraud. For, again, these standards things, it's going to help as a company, my life be much, much easier. I'm not having to store a whole bunch of stuff. And if I do need information, there's certain types of verifiable credentials. Hey, give me an ID. Give me whatever that is. As a user, I'm in control of my those decentralized identifiers. I control them. I consent what I want to share. Again, in the future, we'll have that selective presentation, maybe in zero knowledge proof. It's even better. But I have a consistent experience. I can think of two good examples. YouTube. Once I hit 100,000 subscribers, I could get verified. That proves I'm a real person. It proves, hey, I own that channel. That's not available to someone who has less than 100,000 subscribers because there's a burden of work on YouTube to go through that verification. So it's not available to everyone. Some might have a load of bots, they're not real subscribers. Twitter, they did proof of stake, give me money. And we kind of saw how that went. Well, verifiable credentials would solve both of those things. It democratizes the requirements to go and get verified. Hey, give me your government verified credential. Maybe it's zero knowledge proof that you're an actual real citizen. Here you go. Okay. Twitter, give me your verified credential that proves you're John Savile. Here you go. Done. It democratizes the whole idea of identity by democratizing the whole idea of that cryptography, the public-private key. It makes it available to anyone, which makes the identity available to anyone. So now everyone in the world can have an identity, not just those people that can maybe buy a URL or buy an email or have a phone number, whatever that might be. It starts to make it far more available. There's no financial, there's no popularity. None of that applies anymore. So it's a very, very attractive thing, I think, for everyone long term. Now, with everything, there's considerations. If I think of my wallet for a second, today, if someone asks me for proof, I'm kind of skeptical when someone asks to see my driving license. I'm like, why do you want to see my driving license? As more and more things become these verifiable credentials, whereas attackers today might target an IDP, as the information shifts from an IDP to the individual people, it makes it harder for the attacker. Now they have to target thousands of wallets instead of some big central target, but they'll set up spoof sites that will, if you're not paying attention, say, hey, give me all your verifiable credentials. And if you're not looking, oh, here you go, and suddenly you've given away a whole bunch of PII. So I think what will happen is a certain amount of education, but the wallets and their user interfaces will help protect the user, saying, hey, wait a minute, is this requester, is this verifier really someone you should be giving this stuff to? Do you want to give all of these? Because it shifts the responsibility a little bit now to you and picking who you want to give it to. But ultimately, if you think about this decentralized identifier, these verifiable credentials, when the internet started out, it's a mesh, and it still is. The internet's a mesh. Yeah, it's just networks connected together that have IP routing between them. There's not really a central point. You could argue DNS there is a hierarchy to DNS, but identity has become very centralized. It almost goes against the goal of the internet. The identity providers have become the hub, whereas really when I think about identity, it should be the entity of the real world is at the center. And these decentralized identifiers take us back to that world. If you look at all the pictures I drew, it's the holder is in the middle. So it puts it back to this idea that it's a mesh. It's a mesh of entities. It's a mesh of decentralized identifiers. And through these means, we can still have trust in that system. So I hope this helped. There's a whole bunch of standards around this. Really, if you're interested, there's this great knowledge tree that goes through all of the different standards. And I'll put it in the description. I definitely recommend going and have a look at this. But they're actually very readable. They're actually pretty cool to go and look at. And it can help understand what's happening. So I went in a ton of detail. The reality is you don't need to understand almost any of this. If you just want to use verifiable credentials, I install an app and a user agent, whatever you choose, and I go and request it. You saw the interaction. Oh, here we go. Here you go. I'm consenting, give you this. That's it. But if you have concerns maybe about the use of those and the security, hopefully what I've shown you here is they can be trusted. They are rooted in these very secure, trusted systems and that have this central set of specifications that they're going to behave the same way. But you as a company can choose, well, what method do I feel most comfortable with, what I want to use, and you can go and play. So as always, I hope that was useful. This was actually the most work I've had to put into a video for a really long time. The research for this was crazy. I don't have ever read so many specs in a 1 week period, but it's fascinating. This is a really interesting, I think this is the future in many ways of the internet. If you think at the core of everything is identity and identifiers for our entities, this I think is the future. So it's cool to actually understand and start playing with this. So the next video, take care.